Okay, so now can you hear me? Yeah.
Yes.
Okay. So now we'll start. So I simply share my screen. Okay, so now it's sharing. Yeah. So here you can see. Now can you see my screen? Yeah.
Yes.
Okay. Okay. So in this time here you can see. First of all, I simply import your road, all of the major roads for this region, as well as also import our boundary shape file. We imported in here. Okay. So these two things we need when you want to make the make the distance from road map. Okay. After that, I simply click on here and go to the properties. In this time, I want to check about our projection system. You can see I can get the projection system is that geographic coordinate system. Okay. In this time, the geographic coordinate system, I need to convert into projected coordinate system. Okay. From geographic to the projected coordinate system. So for that, we can simply do that. So I simply click on here and go to the data frame properties. From the data frame properties, we can simply select our projection system. So in this time, I need to use here the projected coordinate system. So projected coordinate system, then I simply go to the UTM, and then your region is that what's your region? Africa, Asia, Europe. Yeah, it's Europe.
Europe.
Yeah, Europe. Yeah. For the Europe, what is the time? Is that UTM 34? Yeah.
Yeah. 34.
Yeah, 34. I check the okay. ERTS, so okay, WGS, ERTS, European datum, lot of coordinate projected coordinate system value in here. Okay, so he's okay. Okay, so in this time, okay, so
You can use ETRS or yes.
what's
You can use ETRS.
ETRS? Yeah, ETRS
89. Yeah.
1989 ETRS TM34. Yeah, is it?
I don't know. I think so. TM34 is the same with Zone 34.
ETRS 34. Okay, so is it or UTM zone 34? Okay, so we try to check about our result first. We can get so use this 34 UTM zone 34 and BG. Okay, so we try to check it and then try to so also it about UTM zone 1900 ETS 1934. Okay, so you use the
I think that's right.
Yeah. So you can use that. So select that and simply apply and okay. Apply and okay. Yes. Yeah. So now it will be get the projected coordinate system which I select. If you want to check again, go to the properties and then simply find out this. You can see the source. From the source, in this time you can see the geographic coordinate system is that look like this about that data. Okay, so I click again. What's happened? I change that, but it's not changed. This apply. Yes. Oh, yes. Now check again. Okay.
I think you can represent them or something.
Okay, I think it's not working. So I simply or it's the northern hemisphere. So we are using here this WJS ATM zone 34. Apply. Okay. I hope now it will be work. Check. Okay, so now it will be work. 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 Okay, so now it will be wor So I did this again. I also imported the road again. Right check. I simply imported the major road. Now we get all of the major road in here, and this is our boundary. Yeah, so now I simply click on here and go to the data frame, and then select this and apply, and okay. Okay, so now check it. Geographic coordinate system geologist United. Okay, so let's go about that. And then we need to okay, so then we simply go to the catalog tool. From catalog tool, we can go to the spatial analytics tool. From the distance, we select the Euclidean distance. And now from the Euclidean distance, we can simply input the raster as a raster. We can simply put here the raster is our road. Okay, and before that, we also need to so in this time, it not showing that because we also need to import the data. So export data, and then simply select our, suppose in this time I simply put this data set name is that projected road. Okay, and then simply save it, then okay. So now in this time all of those things will be changed and also save their projection which I saved. Okay, I want to add the layer as a layer. So in this time it's not need, I simply remove that, it's not need. Now I want to check about this properties and go to the source. We can check the source about the projection. Okay, WGS, okay, PCS WGS 984. Okay, okay, so now check about this special analytics tool and go to the Euclidean geometry, and in this time simply imported the feature projected road, and then output this distance raster. I simply save it such as distance road dot file format is the tip. Okay, and then save it outer. Okay, so it's showing that is road. Then that the tip. Okay, now it's okay. And in this time we also need to put here the cell size as a 30 meter, because our all of the data set land set 30 meter, as well as also DEM 30 meter, all of those data is 30 meter. So that's why we can also select the 30 meter resolution also in here. After that I simply go to the environment. You can see, click on the environment and go to the processing extent. In this time we can simply select our boundary. Okay, so PR same as a layer as a PR, this boundary. Okay, same as a PR, and then all of the things will be same. After that we can simply go to this raster analysis, and then input here the marks with our shape file. Okay, all of the things will be same, then click to the OK, and then also OK in here. So now I hope it will be working, and then we can get the Euclidean distance from road. You can check what the result we can got. Okay, so it's working, and now simply can check about our result. There is a nothing, right? So I try again, I think some problem here. So this is our shape file. Also our boundary. Okay, and now I want to convert this. Right click on here, go to the data frame, and after that select the UTM zone 3084 and apply and OK. So after that, you can simply go to the, after that simply click on here again and then export data. You simply put this name, suppose selected road. You can use any name, then save it. So now you can get all of this projected. Okay, so now it will enter the layer also in here. I also remove this part if need. After that, I simply click on here and go to the Euclidean distance and then select the source file is that projected or all of the road, and also select this. Suppose I put this name such as 10 dot tip format. Okay, then save it, and then cell size will be 30-meter resolution. All of the things will be same. Then go to the environment and then click on the processing extent. I simply select at the same as the layer PR. All of the things will be same. And then we can simply go to the raster analysis, and from the raster we can simply select here the marks with PR or boundary. Okay, so then apply and OK. Now I can check. I think we have some mistake in the projection system, that's why it's not working. Okay, but here I already create a tip image. Okay, so here I already create this map, distance to road, about your data. There is no problem when I want to create this map. Thus you can get this result look like this. Yeah, so this is our map. We created your road map. Okay, so this is the distance to road map. I think there is no problem about this map, and also we need to work with this RY. Simply imported this file. Okay, so this is our distance to road map we created in here, and this is our one data set. Okay, as well as you also need to the other parameter such as well as you also need to use the other parameter such as land use land cover classification map. So I simply import it here. Okay, so 2021. Yes, as well as also you need to put here the LULC. Okay, so we can import it our all of the file in here. but this shapefile is not same with the tip images. Okay, so can you hear me? Hello.
Yeah,
Yeah,
I
yeah.
hear you.
So it's some,
It's
yeah,
Wednesday.
it's some extra part also in here, but our land use land cover map is only for this region. Okay, so
This shapefile was open source, first shapefile. We made the land use uncover,
yeah.
but after that I get shapefile in uh, another shapefile.
Okay, so we need to use the same shapefile. Okay, so in this time, which shapefile we use to create this map, land use land cover classification? Can you send me this shapefile?
I sent you
Yeah,
the
yeah.
first meeting that we have. I don't know if you have.
Okay, so kindly forward this email again. I also check because in this time we need to use the same boundary shapefile in our which we can use in here for the creating the land use land cover classification map. Otherwise, in this time the some extra part also in here, then it destroy our land use land cover classification map. Okay, so that's why we need to max using the same email, same boundary. Then it will be better. Yeah. Okay, kindly send me that. I also download and marks with this same boundary. Then we can get the better result because we can create it all of the land use land cover classification as well as also create the solve map. All of the things we can create it as the same boundary.
Can you see your inbox?
Yeah, so I simply check my
I will send you a link in WhatsApp from Google's engine.
yeah.
If something went wrong, I don't know.
Okay, so kindly send me again this link. It will be removed from here.
Do you want to send you again this link?
Can you send me this WhatsApp? It also better. Or if possible you can also share your skin. I think this shapefile is stored in your asset. Yeah, your asset, your with your Google Earth Engine platform.
Yeah.
Yeah, so then it's also better you can easily download it from your own asset. So can simply share your skin and open the code. I also guide you. You can easily download this shapefile and send me that, because if the shapefile is your own asset, then I cannot download it from your own asset. You can download it. Okay, then it will be, yeah. So in this time simply go to the app hub and write the code. We need to write some code. Okay.
Uh, You need to
and also import this shape file first. And give the name ROI. Yeah. And now simply take a variable name. You can use any variable name. Use the var keyword, then put the variable name. Yeah. Then write here ee.feature collection. ee.feature collection. F is uppercase. F and C. These two things is the uppercase. And also F. Yeah. And then use the parenthesis, first parenthesis. First parenthesis. Yeah, then use here the square bracket. Then call the ROI, write the ROI variable name. Yeah, then go to the second line and write the code. Export table to drive. Export dot table to drive. Dot table to drive. After table, you also make to one dot. Yeah. Then use the parenthesis and press Ctrl space together.
I don't hear you.
Control and space on your keyboard. At the same time, remove the space and again press the Control and space. Your cursor in the middle point of the parenthesis. Take the cursor on the middle point of the parenthesis.
There?
Not the middle point of the parenthesis. Yeah. Then press the Control and space.
I don't understand you. What I need to do now?
On your keyboard, you can check the keyboard, Control button and space button. Just press Control and then space. Yeah, good. Now it's okay. Yeah, now. Yeah, so now make the dictionary. Use the curly bracket start and curly bracket in. Yeah. Curly bracket start and curly bracket in. Not here. After the first parenthesis, then put the curly bracket. And also close the curly brackets before the first parenthesis. Yeah. Not
there.
No, not after. Yeah. Remove that and yeah. Then put yes, done. Okay. Then collection. Use the colon sign in collection. Use the colon sign.
Collection?
Collection, yeah. Colon sign and this not equal. Colon sign. Make the dictionary and keyword. Yeah. Then put here the SSP shape file, your variable name. Write the variable name SSP. Not ROI, SSP. Yeah. Then also put the description. You can use any name as a description. Keyword and key value, yeah. Must be use the quotation. We need to use the quotation. In the PR, just use the quotation, yeah. Single quotation or double quotation.
Right now?
No, we need to use the quotation. Means that it is a string. When you want to define the string, you must be used at the quotation sign. Single quotation or double quotation before start and in part.
No, I don't understand you.
Okay, you can okay, I send you this, so you can simply get the PR look like this. Okay, take your message. So use the quotation first before start and end part. Yeah. Okay, then put that, and folder is the same. You can use any folder name and put the quotation and put this name, any name. Yeah, then file name prefix, remove it. It not need. Remove. Yeah, file format is need. File format is need. Yeah, remove that. Yeah, use the comma sign, and then file format is the SHP uppercase. SHP.
Any of them or not?
Not. Yeah. Also put this quotation. Yeah. Also put this quotation. And uppercase SHP. Uppercase SHP. And all of those uppercase or capital letter.
Is right now?
No, I write this. That's it. It will be
CC or SS?
SHP. Write this. Yeah.
Shapefile.
Yeah,
Alright.
shapefile. Yeah. Then selector not need. Remove that. Max matrix not need. Then run the code and go to the task tab. Open the task tab and click to the run. And check what happened. Problem. So did you have this source file on your local storage? Then it will be better. If you have this source file,
Use that.
then we can easily work with that.
Can you see now?
I simply I got it. Download. Or I want. Yeah, so it's okay. There is no problem. Okay, so this shapefile is the correct. In this time, we also need to. Okay, so this shapefile. Okay, we create this distance to roadmap using this shapefile. In this time, we also need to create this shapefile using this. And before that, we just create the other data set such as land use, land cover. Now I simply use the catalog and the extraction extract by marks. First of all, input raster is that 2021 mark about that, and then put this input raster, and input raster will be our shapefile. Is send me that, and then simply okay. So I put this. Suppose it's the final LULC 2021, and then save it and save. Final LULC. LULC 1. Okay. Then okay. Now it is struck by marks. Okay. Okay. Done. As well as we can also create the another thing is that go to get struck by marks, and in this time input raster as the 1991, and then input as the shapefile, and then here this names of LULC 1991. Okay, then save it, and then okay. Now we can get the another thing is that about this data. Now we also need to use here this another thing is that our solve map. So solve map, I simply import the solve data, solve PPMS, and then here is our shape file, and put here you can put here the suppose name solve name. Okay, and also put here this save it, and then okay. Now it also create the solve map also. Okay, it's done, and from that this time we can simply remove suppose this time it's not need I simply do that. It also not need that, not need I simply do that. So in this time we can get the solve map. So this is the solve map need or one factor for this like the prediction of the urban growth. So I put this color look like this, suppose apply and okay. These are solve map got in here, and these are land use land cover classification map. I will change the color for suppose this time 0. What is the 0? What is the class of 0? It's water. Take it.
Yeah, it was.
Water. First is that water, and then second is that
Uh, one is build-up area.
build up, and 2 is that
Yeah.
vegetation,
Second is vegetation.
and 3 is the others.
Yeah, ours.
Color look like water as a blue color. The will I put at the red color. Vegetation put at the green color. Others I will put as a. Then I can simply add this apply. The apply simply export this color ramp, then simply download and save it, then apply and okay. And now I want to use the same color plated also in here. So for the click on here, the properties we can go to the color ramp. In this time we can simply import and go to the download and simply select this file. Okay, now same color we can got and write the names of the water, and then second is that build up, then get the vegetation, and put at this others. Apply and we can get the three types of data. Class, class land use land cover class. This is the actual land use land cover class we can got, and then we need to also got here the another thing is that for the solve map we can also got in here. Okay, and this time we also create the distance from road map again, or distance from road map. This time we already created for the another shape file distance from road map, but we need to create this map for this region. Okay, this time we can see the some region is not covered, so this time we also need to create this shape again. So I simply remove the previous one and then try to make this shape file distance road map again. So for that I simply imported the bound road area again, measure roads. Measure road. major road. Let this major road here. Now I need to just can see all of the road will be existing in our boundary. For that, first of all, I simply take their coordinate them, saying this WGS. So then I simply click here the data frame properties and then select this WGS 984 UTM zone. I think it will be in WGS 984, Northern Hemisphere 34 by. After that, on here again and go to the export data. This name and they are road projection the data frame. Then oh, yes, and I simply refresh. Okay, so again it will be set it, you can see. Okay, so now it will be showing as a projected coordinate system. Okay, so now it's showing as a projected coordinate system, and now we can easily work with that in the projected coordinate system. So we can also create this distance from roadmap from here. Okay, so let's go. So for that, in this time, I simply go to this special analytics tool from the catalog. Go to this and go to this in here the special analytics tool. Go to the distance from the go to the Euclidean distance. Click to here and then input feature as our projection road. Then also set here the distance. I essentially put here this is that. I put this thing suppose distance from or put the new sample new, okay, the new and put this file format is that tip. Then save it and the cell size will be 30-meter resolution, so it will be 30 all time. We use at the 30 and go to the environment and first of all we can select here the processing extent. So processing extent is the default as use here this go to the display and select here the bilinear interpolation, then you can get the better result. And also symbology, I want to see here the total suppose 5 plus and apply. And so this is our distance from roadmap we can also get in here. Okay, so in this time we can get all of the factor which we want to need. So first of all we can get the distance from roadmap, then get the solve map for our region, and also get the land use land cover classification map for the 2 time period. In this time we also need to the another factor. This is the population density. Okay, population density. For the population density you already provide me the data. We take it. So your data set is that Excel file. Okay, take it the data. Okay, so is it the different types of cities or state for this region? Yeah, and it is the population number. Okay, so in this time we also need to take our attribute table about this boundary. This is our boundary. I simply go and go to the attribute table.
It's difficult to match this shapefile with the Excel. That's the reason why I created the next shapefile, which I sent you.
Yeah.
The second.
Okay, so in this time you can see there is the no attribute table is not
Yeah.
mask in other region is not available in here. Okay. Problem. Okay, so in this shapefile we can get only for the boundary. Only for the boundary. No other types of cities is not available in here. So that's why this is the problem. And this shapefile, okay, this shapefile is available for all of those things. Okay, so this is the problem. And this shapefile attribute table, we can take it. Here we can get all of those cities name. So I think we should follow this shapefile and create the land use land cover classification map, and all of those data we need to create according to this shapefile. Yeah, and then we can easily
Yeah,
get the population density.
I wanted to check my code when I send you because I want to change the period of years and change my shapefile and all of data and to and then to predict the urban growth.
Okay,
That's the reason why I send you my code and my new shapefile.
and understand about that.
I want to prepare all of these things in this format and start to predict the urban growth.
Okay, there is no problem. In this time, we can also do all of those things using this shapefile. And in this time, all of the cities. Okay, so which column are available in here for this attribute table? Which column? What is the column?
Catastrophe one, yeah, is the same.
Yeah, same column. Yeah, okay. So we need to linking with this column in this column. Okay.
Yeah, we need to join this table with that shapefile.
Yeah. So for that, we also need to use the same column name also in here. Okay. So which column are available in your attribute table? We also need to use here the same column name also in here. So then we can easily joining with this shapefile and create this density map from here. Okay, so okay, but in this time we can create all of the things using in here. This is another problem.
Can we do just with slope and distance?
Yeah. In this time, so in this time, we need to use this shapefile, new shapefile, which you send me. This shapefile we need to use, and then make the all of the things: land use, land cover classification, then distance to road map, then solve map, then also make this all of the things we need to create using this same process. Because in this time there can also get the some district or other things, so that's why we can easily make the population density map using this data set. So that's why we need to use this data set and then try to make this population density map in here for the different cities. Okay. So in the meantime, we need to work for all of those things. Okay, so basically in this time we need to the total first of all distance to road map, we need solve map, land use land cover classification for 2 time period, and also need the about the data set for your population density. Okay, so in this time we need to use this shapefile. This shapefile we use, and also create the population density map, and then also create all of the things using this boundary shapefile, and then create all of those data as a factor, and then we ready to make this prediction for the using the Python. Okay, for that give us some time. Okay. First of all, land use land cover classification. Okay, so can you send me this code link again? Please you send the shapefile. Just send me the code link again. Please you send me the for your new shapefile boundary. Okay, I take it. Okay, so I think your asset is not shared with me. You can see not found this asset. So simply share, then you can easily access for the asset. Simply click on the
Yes.
and then share it. Then
Yeah, I'm sharing my screen. I share with you this, but I don't know why.
then
Now I need
then you
to
can
write here.
yeah, email, yeah. Write my email.
I'm doing that, but I don't know why it's not.
Uh,
Writer, okay?
yeah, writer. Yeah, then done.
It's okay now.
Yeah, then done. It was done. So now I reload this again.